Welcome to Learning Intention 5, Using Significant Figures. In this video, we're going to have a look at a topic called significant figures and how we can use it to better represent numbers. So in the previous learning intentions, we've had a look at index notation, so a base raised to the power of n, and we looked at the rules that you can apply to deal with said numbers. In Learning Intention 2, we had a look at what happens when we've got a negative index. So what happens if we've got a base raised to a negative index? In this case, a times b to the power of negative n becomes a over b to the power of n. Going onwards, we had a look at scientific notation. So in this case, making a number easier to read. And today what we're going to do is build on this notion of scientific notation. So we've found out a way to make a number easier in its representation, but rather we want to now look at how we can make it more compact. Now jumping into it, consider the distance from the Sun. The Sun is roughly 150,472,734,983 meters away from the Earth. Now, do you think this is an intuitive way to represent the distance from the Earth to the Sun? So just have a think about it. What about if we change the representation? So if I change it using scientific notation, we can say that it's 150.472,734,983 times 10 to the 9 meters. Does that make it easier? What about 150.472,734,983 gigometers? Do those numbers really make a lot of sense? Do we need to include all of them? On another example, consider you've got a drone, and to keep your drone in the air, your battery voltage has to be above 14.4 volts. If it dips any lower, you won't be able to turn the motors fast enough to keep it in the air. Now your controller tells you the voltage during real time, and at this point in time it says that you've got 15.97826447,928 volts. Is it intuitive? Do you need to know all of those numbers after the decimal point? So that's where significant figures comes in. In significant figures, we look at representing the meaningful part of a number. The reason being, if we have the meaningful part, we can get rid of all of the distraction in between. So this brings us to Learning Intention 5, using significant figures. So to represent a number in significant figures, first we convert the number into scientific notation. Now we don't always have to do this, but typically to make the number more legible, we convert it to scientific notation. Secondly, we identify the meaningful part of the number, or the significant part. And then finally, we remove the excess figures, rounding either up or down depending on the final number that's just outside the most significant figure. Looking at example, 8,976,634 expressed to three significant figures. So on the left, just over here, you can see I've written out the number. Then on the right, I've converted it to scientific notation, and then three significant figures. So in blue, I've highlighted three numbers, and then in green, I've highlighted this fourth number. So these three highlighted numbers here represent the three significant figures, but we're not done. We have to see what this fourth number is to determine what the final significant figure should be in our number. So notice that it's above 5, it's 6, so it's above 5, so we're going to round up. So this 7 over here changes from 7 to an 8. So the answer would be 8.98 times 10 to the 6. So notice how this number here is much more easier to read or easier to digest compared to this number over here. Going on to a few examples, consider 8,723,456 to three significant figures. Well, to do that, first I'm going to convert it using scientific notation. So I'll go 8, 7, 2, 3, 4, 5, 6. I'm going to drop the decimal point just here, and then I know it's going to be times 10 to the how many? We'll go 1, 2, 3, 4, 5, and 6. So it should be times 10 to the 6. Now up here it says three significant figures. So I'm going to say 1, 2, 3. Looking at this fourth one here, it's 3, so therefore I don't need to round up, I'll round down. Therefore the answer will be 8.72 times 10 to the 6. Part B, express 2 root 3 to two significant figures. So this particular number here, it's called a surd, or it's an irrational number in that if I type root 3 into my calculator, I'm going to get a number that goes on forever. Now, typing it in the calculator, I get roughly 2 root 3 is approximately 3.464101. And the question at hand is two significant figures, so we don't need to be particularly accurate. So I'm going to count my figures here. 1, 2, and the final one here, 3. So the answer is going to be 3.5. And notice that this 4 changed to a 5. That's because 6 is greater than 5, so I'm going to round upwards. So I'll go 3.5, two significant figures, and I can say times 10 to the 0. Or I can just drop it because we're all about being succinct in our answers. 10 to the 0 is just 1, so it's easy to write 3.5. And finally, express 299,792,458 meters per second to two significant figures. Now, firstly, do you know what this number is? It's actually a very famous number in physics. Did you guess it? It is the speed of light. So, rewriting this as, or in scientific notation, it will be 2.99792,458 times 10 to the 8. So 1, 2, 3, 4, 5, 6, 7, 8. And using significant figures, we want to express it using 2. So that's simply going to be these two here, and then looking at this final one, this 9 will round this 9 word up, and this 9 will also go upwards, so it will be 3.0 times 10 to the 8 meters per second. So, just out of interest, go to Google and type in speed of light, and Google will actually tell you that the speed of light is 3.0 times 10 to the 8 meters per second, where in actuality a more accurate answer would be 299,792,458 meters per second. But the point is, we can use this calculation here, 3.0 times 10 to the 8, because sometimes we don't necessarily need to be as accurate as over here. Now that was looking at expressing large numbers using significant figures. Let's have a look at using smaller numbers. So over here we've got a number of different examples. Whoops. Here it is, expressing small numbers with significant figures. So part A is 0.0072634 to 3 significant figures. Well, here's where it gets a little bit more difficult. Firstly, we're going to rewrite this using scientific notation. So I'm going to drop all of these zeros in front and I'll simply write 7, 2, 6, 3, 4, and I'll drop the decimal point where it needs to be. Now that's going to be times 10 to the something. Well, what's that number up there? I went back 1, 2, 3. So it's going to be -3 because I moved the decimal place back 3 places. And it's asking express to 3 significant figures. Well, getting those ones, it's going to be 1, 2, 3, and looking at the +1 here. So 3 is less than 5, so I don't need to round upwards. So I can simply rewrite out 7.26 times 10 to the -3. So this number here is equivalent to this number up here, but expressed to 3 significant figures. Now going down, B, the 1 over, or tangent of 60 degrees raised to the power of -1, expressed to 4 significant figures. So this is an interesting one. I'm going to use my calculator to do this one. So I'll rewrite out tan of 60 degrees, ensuring that my calculator's in decimal mode or degree mode instead of radians. I'll type in tan of 60 to the power of -1. And again, that's an irrational number, so it's going to give me 0.5773, and there's a few more decimals after that, but I won't write them out because they're simply not necessary. Now using that or expressing that in scientific notation, it's going to be 5.7735 times 10 to the -1 because I moved the decimal place to the right by 1, and then using 4 significant figures. So let's count 1, 2, 3, 4. Those are the ones we're going to use, and then the 5. Notice that this 5 here, it's 5, so we're going to have to round upwards. So rewriting this out, it will be 5.774. So this 3 turned into a 4 because the 5 rounds upwards, times 10 to the -1. So tangent of 60 degrees, all raised to the power of -1, expressed to 4 significant figures, is 5.774 times 10 to the -1. Now, final question. Express, wow, I can't even read that. Express 1, 2, 3, 4, 5, 6, 7. So 6,626,070.04 times 10 to the -40 meters squared kilograms per second to 2 significant figures. Now, this is an interesting number. Let's write it out and we'll convert it to scientific notation. So 6626070.04 times 10 to the -40. Now we're going to move the decimal point from here over to here. So we jumped 1, 2, 3, 4, 5, 6. So we're moving the decimal point 6 places to the left. So that's going to become times 10 to the 6. Now using my index laws, negative 40 plus 6, that's simply going to become 6.626070004 times 10, negative 40 plus 6 is 34. And then two significant figures. That's going to be 6, 6, and looking at the 2. Thus, we're going to get 6.6 times 10 to the negative 34. So this particular number here, it's actually a famous constant in physics as well. It's called Planck's constant. If you do physics in year 11 and 12, you'll definitely see this. But this is Planck's constant down here expressed to two significant figures. So moving onwards, let's have a look at our previous examples. So at the start, we considered the distance from the sun and we asked ourselves, is this a meaningful way of representing the overall distance from Earth to the sun? Noticing all of the decimal places back here. And I'm going to say probably not, because these decimal places don't actually tell us anything useful. Considering the overall distance, where it's over 150 billion meters away, what is 983 meters to 153 billion? Or what's even 700,000 meters to 150 billion? It's not that much at all. So in this case, I decided let's just represent it to 5 significant figures. Whoops. 5 sig figs. Now again, in the questions that I give you during, say, for example, a test, I'll probably tell you how many significant figures you need to express the answer to, but in real life applications, it's generally up to you to figure out for yourself what is the most meaningful way to express a number. And in this case, I thought it would be 5. Going down to our battery voltage here with the drone, did we think this number was intuitive? Well, again, no, not really, because 15.9782647,928, what does that actually mean and what do we care about? Well, we care whether the voltage dips to 14.4. So I concluded that any number after or any number above 4 significant figures is superfluous, because we don't really care what these particular numbers are here. We just want to make sure that it's above 0.4. So for observability's sake, if we go to 4 significant figures, we can see it as, or we can see on the 4th significant figure as the voltage approaches 14.4. So again, in this case, it's all about intuition. You have to decide which numbers are actually meaningful in the calculation, and in this case it was just 4 significant figures, or if you really wanted to, you could say you only need 3 significant figures. So in summary, what we did was we asked ourselves, using significant figures, where are they useful? Well, significant figures are a means of representing the meaningful part of a number. Then we had a look at how to do a few examples, which we did here. So converting large numbers using significant figures, and then finally expressing small numbers with significant figures was done here.